MITRE Ingenuity's attack framework is today's de facto standard for describing adversary tactical objectives and the techniques they use to achieve them. The latest attack evaluation is a simulation of the Carbonac and Fin7 adversary groups. Their objectives? Breach, move quietly about the network, then identify and steal financial data. This video is the perspective of the adversary methodically executing one attack technique after the other and moving laterally among 6 Windows devices and 1 Linux server. This attack emulation is segmented into 20 major steps and consists of 174 sub-step techniques. SentinelOne Singularity EDR is set to a non-block mode, and the adversary is permitted to do their dirty work. The result? Singularity EDR automatically tracks the adversary in real time, placing all the data into easily understandable context. Singularity EDR misses nothing and provides 100% visibility with no config changes and no delays. Over 2 days of testing, the SOC analyst is presented with a total of 7 campaign-level console alerts describing what Carbonac and Fin7 did and who was affected. As our simulation is presented, keep your eye on this real-time counter that is synchronized step-by-step to the actual attack emulation data from the MITRE Ingenuity website. The counter tracks attack analytic coverage, missed detections, delayed detections, and the quantity of configuration changes the vendor made during the test to improve product detection performance. Let's begin. Day 1 starts with the Carbonac adversary group's attack methodology. The initial breach occurs on the HR manager's PC when she opens a tainted Word document that contains an encoded script designed to misuse Microsoft Office. The script is stealthy and creates other scripts from content within the evil document. Covert communication begins with the adversary's command and control system, also known as the C2. The adversary performs reconnaissance to learn vital information about the environment. He downloads a tool from his C2 server, takes a screenshot of the HR manager's PC, then uploads the image back to his C2. The adversary deploys a malicious toolkit onto the PC and modifies the registry to provide mechanisms to utilize various components. Evil hacker now initiates brute force credential access techniques, probes the network, and tests the stolen credentials on other hosts. More malware and scripts are downloaded from the C2 that are used to dump the PC credential database. Lateral movement now begins. Using the stolen credentials, the adversary moves laterally to the Linux OS bank file server and copies tools onto it. Masquerading as the bank file server, the adversary successfully completes a pass-the-hash attack against the Bank DC Windows domain controller. He is now masquerading as the domain controller, where he spawns shell code that connects back to his C2 server. The adversary is inside the domain controller, where he performs more account and remote target reconnaissance. From Bank DC, he accesses the CFO's laptop via a remote desktop session. He's now the CFO, and he downloads a fake Java update and more scripts engineered to gain and maintain persistence. When triggered, the fake Java update creates a new covert communication channel with the C2. More malware is downloaded to the CFO, including a keylogger, screen capture software, and browser credential scrapers. The real CFO has no idea his sensitive information is being logged and uploaded off the network. In the last step, the attacker makes it easy to get back into the CFO's laptop at any time and from anywhere by adding a VNC remote access server and poking a hole in the local firewall policy. Carbonac is now directly embedded into the CFO's laptop, and critical information is being stolen in real time. This completes attack evaluation day 1. SentinelOne maintained 100% detection visibility throughout all substeps. Now let's pivot to attack evaluation day 2 to demonstrate the Fin7 adversary group's attack methodology. The initial breach occurs on the hotel manager's PC when he's tricked into opening a poisoned Word document, instrumented to misuse Microsoft Office and other Windows OS components for nefarious purposes. The Word doc becomes a source of code for other scripts that the attack builds on the fly from innocent-looking data. This step ending with the insertion of a scheduled task 5 minutes from now. 5 minutes have elapsed, and the adversary triggers an evil JavaScript built from the original Word doc. The script performs network reconnaissance, then connects to another host called MS-SQL, from which it downloads a PowerShell script to be used later in the attack. The hotel manager's PC continues to execute the malicious script and performs extensive environmental reconnaissance abusing the built-in OS functions. It even tries to figure out if it is running in a sandbox in order to evade analysis. The adversary takes a screenshot and uploads it to his command and control, or C2 server. The mischief continues on the hotel manager's PC, as the script abuses PowerShell to load shell code from memory. A new network connection is made to the C2 server. Evil hacker downloads malware from his C2, then triggers it within a PowerShell spawned from another PowerShell. The local OS's credential store is dumped for his use. More malware is downloaded from the C2 server. He then pivots attention to the IT admin computer, makes an SMB connection to it, and executes a technique called process hollowing in order to harness portions of the remote host memory for his purposes. The adversary is now operating from the IT admin computer. He downloads a fake copy of a Windows DLL from the C2 for privilege escalation. The attacker continues to misuse legitimate OS components with fake ones and exfiltrates keyboard inputs and screenshots from the IT admin computer. Using stolen credentials, the adversary moves from IT admin to the accounting server. He misuses Windows Remote Desktop in an unusual way to proxy communication from his C2 to accounting via his IT admin session. He now achieves persistence on the accounting server by misusing the legitimate accounting application. Next, he locates customer financial data, compresses it, and exfiltrates it to his C2 server. Then 7 achieves its objective. Though these MITRE Ingenuity attack emulations produce hundreds of data points, SentinelOne Singularity EDR makes it easy for security analysts to know what's happening by automatically correlating everything into 7 simple console alerts. Over 2 days of testing, Singularity EDR misses nothing and provides 100% visibility with no config changes and no delays. SentinelOne Singularity brings actionable intelligence to EDR. For more information, visit us at s1.ai/MITRE.